Alright, I know I told you that the last ones we did were going to be the last examples of factoring special cases of binomials, but these are really the last ones, I promise. And you'll be happy that you're watching them because these are going to be a little bit more challenging. So let's start with this one, 32x to the fourth minus 18y to the fourth. See, I told you they're more difficult. So we're always going to start out the same way. We're going to look for greatest common factor. The greatest common factor in these terms is going to be 2. Woohoo! 2. So we've got 16x to the fourth minus 9y to the fourth. Now with these two terms, remember we're looking for the two terms to either be perfect squares or perfect cubes. And you look at 16x to the fourth, that's going to be 4 times 4 to give you 16, and x squared times x squared to give you x to the fourth. And then 3 times 3 to give you 9, and y squared times y squared to give you y to the fourth. So this actually is difference of squares. For difference of squares, we want to see first what is our f term, which is going to be 4x squared. And then next we want to see what is our L term, which is going to be 3y squared. And then difference of squares, f squared minus L squared factors into f plus L times f minus L. So we will factor this into the greatest common factor of 2 times f plus L, so 4x squared plus 3y squared, times f minus L, 4x squared minus 3y squared. Okay, that one was pretty fun. So let's go on to the next example, which is going to be, hope you can see this color, it's a little difficult, 4x squared plus 25. We're going to start, of course, by looking for greatest common factor, and there is not one. And then we look to see if those two terms are perfect squares or perfect cubes, and if it's addition or subtraction. Looks like we've got a perfect square here and a perfect square here with addition, so this is going to be sum of squares, which was f squared plus L squared factors into f plus Li times f minus Li, back to those imaginary and complex numbers. So we'll identify what f is. F is 2 times x, and L is 5. So we can factor 4x squared plus 25 into f plus Li, so 2x plus 5i, times f minus Li, 2x minus 5i. Let's try this one right here. Got another one lined up. It is 27x cubed minus 64. Now this one looks pretty easy. Now let's check for a greatest common factor, and there's not one. So then we look for our pattern. I've got an x cubed, so I'm thinking it's probably cubes. 27 is 3 times 3 times 3, which is a perfect cube, and 64 is 4 times 4 times 4, so also a perfect cube. So we've got difference of cubes, which is, of course, f cubed minus L cubed equals, and our pattern is FL in the first parenthesis, and then f squared, FL, and L squared in the second parenthesis, and then we fill in the gaps with SOAP, S-O-A-P. So same sign as the problem, minus, opposite sign, plus, and always positive. Now we just have to figure out what F and L are. F would be 3 times 3 times 3, so 3, and then x times x times x is x cubed. L would be 4 times 4 times 4, so L is 4. And then in our pattern, we're going to factor this into f minus L, so 3x minus 4 times, in my second parenthesis I have f squared, so this is really going to be 3x times 3x, which is 9x squared, and then plus FL, which is 3x times 4, which makes 12x, and then plus L squared, 4 times 4, which is 16. So far, so good. This is, drum roll please, the last example that we are going to do for special cases of binomials. I know you're going to be disappointed when it's over, but it's been a fun journey. Here's our last example. Negative 8x to the 6 plus 27. First thing we want to do, of course, is look for a greatest common factor. Wait, before you say there isn't one, remember that we do not prefer to factor when our leading coefficient is negative. So let's go ahead and factor out a negative 1. So when we factor out a negative 1, we'll have negative 1 parenthesis. That changes the sign to positive 8x to the 6, changes this sign to minus 27. Then we're going to look for a special pattern. I see a subtraction sign, so it's going to be, if it's anything, it'll be difference of something. And I know that 8 is 2 times 2 times 2, which is a cube, and 27 is 3 times 3 times 3, which is also a cube. So there's going to be difference of cubes. So we have f cubed minus l cubed equals, again, that f squared, FL, L squared. Fill in the gaps with soap. Same sign, opposite sign, always positive. And start picking out what F and L are. F would be 2 times 2 times 2 to get 8. And then x squared gives you x to the 6, so 2x to the second. And then 27 is 3 times 3 times 3, so L is 3. When we factor our original problem, we put our greatest common factor of negative 1 times f minus L, so 2x squared minus 3, times f squared. This gets a little tricky. 2x squared times 2x squared. That's going to be 2 times 2 is 4, and then x squared times x squared is x to the 4th power, plus f times L, so 2x squared times 3, which is going to be 6x squared, and then plus L squared, so plus 3 times 3, which is 9. Uh-oh. I found another problem. Do you want to do it? Do you want to do this last problem? It's kind of a doozy, so if you don't want to do the problem, stop the videotape here. I really did not mean to lie to you. If you want to look at the problem and then decide, let me get it written down. It's a whopper, I'm telling you. Give me a second here. It's a lot to write. Okay, here's what I promise is the last one. If you're still with me, this is the very, 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 very last one, I promise. But it looks difficult, right? So if you're up for solving it, let's go ahead and start with the greatest common factor. The greatest common factor for these two terms, 375 is divisible by 3 and 648 is divisible by 3. So let's start there. 3, and this has 6 x's, this one has no x's. We have 3 y's here, 6 y's here. So I have 3 y's in common. And then this one doesn't have any z's and this one does. So let's start by taking out 3y cubed and see if that leaves us anything else in common, because we can always take more out later. 3 out of 375 goes 125 times. And then we have x to the 6, and we're taking out 3 y's, so there are no y's left, plus 648 divided by 3 is 216. And then I'm taking out 3 of those y's, so I have y cubed left, and I'm not taking out any z's, so I still have z to the 9th. Now I'm looking at the coefficients here. 125 is only really divisible by 5, and then 25. And 216 is divisible by a bunch of 2's and 4's and stuff like that. So these are not going to have a greatest common factor. So we got the whole greatest common factor the first time. Now let's look for our pattern. I have two terms, so I know it's going to be sum of squares, difference of squares, sum of cubes, or difference of cubes. With all these 6s and 3s and 9s in my exponents, that's leading me to believe it's going to be cubes. So let's try for sum of cubes, which follows that pattern. F cubed plus L cubed is equal to, we have F and then L and then F squared, FL, and L squared. And we fill in with SOAP. So we've got same sign, positive, opposite sign, negative, and then always positive on that last term. Let's figure out what F and L are. F and L. What times what times what could give you 125? Well, I'm thinking 5. 5 times 5 is 25, and then 25 times 5 is 125, so it'll be 5. And then in terms of x's, I know x times x times x is x cubed, so I need x squared times x squared times x squared to give me x to the 6. So 5x squared. And in the second term, let's see, 4 times 4 is 16. 16 times 4 is 64, so it's not 4. Let's try 6. 6 times 6 is 36, and 36 times 6 is 18, 20, 216. So it's 6. 6, and then y times y times y is y cubed, so 6y. And then for the z's, I need 3 sets of z cubed, so it's going to be z cubed, z cubed, z cubed, z cubed gives me z to the 9. So that's my L term. Then I just have to start filling that in. So this is going to factor into my greatest common factor, which was 3y cubed times f plus L. So 5x squared plus 6yz cubed times f squared, which is going to be 5x squared times 5x squared, which will be 25 and x to the 4th. 25x to the 4th. Minus, this one's got to be f times L, so 5x squared times 6yz cubed. So I do the 5 times the 6, I get 30, and then I have x squared times y times z cubed, and then plus, this space is going to be tricky also, L squared, we have 6yz cubed times 6yz cubed. So 6 times 6 gives me the 36, and then y times y is y squared. Z cubed times z cubed is z to the 6th. That's the final answer. 3y cubed times the quantity 5x squared plus 6yz cubed times the quantity 25x to the 4th minus 30x squared yz cubed plus 36 y squared z to the 6th. Thanks for sticking in there and working through this problem with me. Good luck with your assignment.